Hi everyone. Moving on to our next lesson. Remember, we already did two lessons in this unit. We did arithmetic sequences and geometric sequences. So now we're going to do what are called arithmetic series, and the final lesson is going to be geometric series. So there's only 4 lessons here: arithmetic and geometric sequences and arithmetic and geometric series. All right, so let's talk about what a series is compared to a sequence. It's really kind of the same thing with one extra little step, okay? So what is an arithmetic sequence? Remember, let's just write one out here. Let's start on 2 and let's go up by 5 each time. So 2 plus 5 is 7. 7 plus 5 is 12. 12 plus 5 is 17, so on and so forth, right? All right, so remember how we had a starting number, right? We needed a starting place, okay? And arithmetic means that we have a common difference, right? Which basically means we're adding or subtracting by something. So in this case, we are adding 5. That's what makes it arithmetic. Remember, with geometric, we are multiplying. So this is a sequence, right? A sequence of numbers, an arithmetic sequence. Now, what a series is, it's just literally one thing stuck on top of that. When we say we have an arithmetic series, it's the sum. It's what you get when you add all these numbers up. So in other words, if I was going to go 2 plus 7 plus 12 plus 17, right? If I add, and what do we get? 38, I think. So there you go. That would be the answer to that, right? To the series, okay? So the series is the sum. What do we get when we add them up? So for a small amount like that, just 4 numbers, it's pretty easy to find. We don't need a formula or anything for that. But what if we had hundreds of numbers or thousands of numbers, okay? So why is this kind of stuff important? These are the kind of, learning about sequence and series is starting to learn about really important formulas in math. That are used in all kinds of things, particularly in the real world, in the business world and finances. Think about if you're earning interest on something in a bank account, and there's a lot more stuff that goes into it than just the basics. Well, these things, series basically can be used to calculate how much money you'd earn over time, right? So that's kind of a really short answer to it. We're gonna do one more unit after this, our final unit, which is going to be doing a little bit of financial work. So this will lead into that. Now, you're going to see the phrase partial sum most of the time. All right, so what do we mean by a partial sum? Well, technically, what if this sequence went on forever, right? Why do we have to stop? What if we just kept going, right? Like, what if we add another 5, right? And we get to 22 and another 5 and get to 27, right? We could do this all day, right? We could just keep finding more and more numbers. Okay, so what they do to address that is we just say, well, let's find the partial sum. Maybe the first n numbers, so like the first 4 numbers or the first 50 numbers, right? So when we say Sn, that means the sum of, so if I write like S20, that means give me the sum of the first 20 numbers in the sequence, right? That's generally what it means, okay? So a sequence is just a pattern of numbers, right, that have a starting point, and they continue in sequence, right? Adding or subtracting, because it's arithmetic, by a certain number. And a series is what we get when we add them up. So let's look at the formulas that we'll want to use for this. And your textbook does a breakdown of how these formulas are built. I won't bore you with a half-hour breakdown myself. For those of you who want to read it, there's a page that shows you how they make these formulas. It is kind of interesting. I guess I could make a video, but just given the time where we're at right now, I think I'll just leave it to, if you want to read about it, you can look up videos online too. I'll just get to what we really need now, because we're kind of hitting crunch time, right? I think we have 5 weeks of school left here, so let's check it out. Okay, so we got 2 formulas here to define the partial sums. Remember, partial sum just meaning adding up however many numbers, the first 20, the first 30, the first 100, whatever. So the sum of the first n terms, so n is going to represent the number of terms that we're going to be adding in our sum, right? How many of them? Okay, and there's 2 main equations we can use. We can use this first one here. Now use this one if you know the first and last terms of the sequence. Now this one you're going to use less frequently, so I'm just going to write above it, we're going to use this one less often, because often we don't know the final term that's going to be there. Sometimes we do though, and if we do, this is the faster formula to use, okay? The second one here is the one we use more often. So when you're doing your homework and trying these out, you're probably more times than not going to use this second formula. So second formula, if you know the first term and common difference, all right? So that's going to be generally what we do. So let's look at a few examples here. And let's look at our formulas here really quick, right? What do we know in the formulas? Well, Sn, that's our partial sum, right? In both cases, it's the same. Now, with the shorter formula, T1 would be your first term, right? The 1 meaning first, right? So term 1. So if you remember back to our previous formula, T1. Tn would be the last term if we're saying there's n terms. So if there's 20 terms, and we have T20, that would be the last term. And n is going to be the number of terms in the sequence, and the same thing, the last term number, right? So if you have 20 terms in the sequence, then T20 would be the last term. All right, now the other formula, n, again, represents the number of terms in the sequence, okay? Or the number of the last term, it means the same thing, because if you have 20 terms, again, right, the last term would be term 20. A is your first term, and D is your common difference. So that should be familiar to our previous formula. Remember the general term formula? This is a variation of that formula. Like I said, our textbook has a nice breakdown of it. All right, so let's look at a couple here. Let me just move this page up so I got a little extra room here. All right, so let's look at this first one here. All right, so find the sum of the first 30 terms of 3 plus 8 plus 13 plus yada, yada, yada. Now, again, we don't want to sit there and do this by hand. We want to start mastering how to use these formulas. No matter how simple or complex the question is, the point is to start using the formulas, not do it the old school, grade school way where we just sit and add them up forever. All right, so what do we know here? Well, we don't know the last term, so we can't use this formula, right? Because this would only work if we knew what the final term was. They only tell us, here's the first, here's the second, here's the third. So if we were going to label these, this would be term 1, this would be term 2, this would be term 3, and so on and so forth, right? All right, so A is term 1. So we're going to use this formula over here, right? So we need A, the first term, which is going to be 3. And we need to know our common difference. Well, what are we increasing by here each time? It looks like we're going up by 5, right? So our common difference is 5. Pretty simple, that's it. All right, so let's get our formula here, right? Sn equals, I'm just going to write the formula out from above. I got to really squish it in here. The number of terms times 2 times the first term plus n minus 1 times the difference divided by 2. Now, this seems like a pretty wacky formula. Now I'm kind of regretting not developing it, but again, you can look it up in your textbook. It's neat how it's developed, but let's just move on with it here. Okay, so we're going to find the sum of the first 30 terms, right? So we're going to write S30. And we write that 30 a little bit lower. It's called subscript, right? So just like our term numbers down below, okay? All right, so that allows us to differentiate between different terms, different sums, etc. All right, so now we just got to substitute everything in here, right? We got to substitute in the 30 out front, right? So 30 times 2 times A. All right, well, A is 3, so we have to double the first term. Then we're going to add the number of terms minus 1. So again, we want to do 30 terms. Now again, the formula seems kind of wacky until you've seen how it's developed and where it comes from. Let me just squish this all in here. The difference is 5 divided by 2. And the rest is punch it out. So this is like your starter beginner question, right? We'll kind of work our way up through more difficult questions. Now, when I do this, what I like to do, I generally just reduce this number out front with what's on the bottom right away. So 30 divided by 2 is 15, right? So I can just get rid of the fraction quickly. What do we got? 2 times 3 is 6. 30 minus 1 is 29. 29 times 5 is going to be 145. So we're going to go, all right, what's 6 plus 145? 151 times 15, 2,265. All right, so that is the sum of the first 30 terms if we added them all up. Cool? So there's a nice simple starter one. All right, let's check out the next one here. First 25 terms of this sequence. Well, our first term, right, is 17, so A is 17. Our difference, in this case, we're adding a negative number because we're decreasing, right? So really, we're subtracting what here? It looks like we're minusing 6 each time, so D is, the common difference is negative 6. And N, I guess I should have wrote that over from my other one in my little tally area over here, was 30. So N in this one is 25. Right, so there's all the values we need to substitute into our formula, right? All right, just to save room here, I'm just going to start substituting in right away instead of writing the formula. All right, so S of 25, first 25 terms. Now, we should get a negative value for this, right? Because these numbers are going into the negatives really quickly. Like the next term here is going to be negative 1, and the next one's going to be negative 7, right? So we should get a negative sum here. All right, so let's just, man, I didn't give myself a lot of room here. Right? Let me zoom in some more. Sorry, everybody. I know it's super, oops, that's zooming out. I know it's super fun to watch me do this. Here we go. That would have been smarter to do right off the bat. All right, here we go. An old man and his computer. All right, so here we go. Let's sub everything in. So what do we have? 25 this time, times, it's supposed to be 2 times a, so 2 times 17. What do we got? Plus n minus 1, so 25 minus 1, times the common difference, which is -6, and divided by 2. So again, right away what I like to do is I like to just reduce this. I like to take the 25 out front and divide it by the 2, so that's going to give me 12.5 out front. So I got 12.5. 2 times 17 is 34. 25 minus 1 is 24. 24 times -6 is going to give me -144. And there we go. And now you're going to subtract those. So we got 12.5 times -110. Multiply it, and boom, you got -1,375. So that's what happens if you add those numbers up, right? So this is, in some ways, simple. It's just simple patterning. We're just getting the sum of what these simple patterns are, right? That's all this is right now. So something so simple, though, can be used to do some much more complicated math down the road, which is coming up soon. All right, the last one. Find the sum of the first 20 terms. Now check this one out. This is the one that always throws people off because you get rolling with those other ones. The first 20 terms, they tell us the first term, and they tell us the 20th term. So that would be the last term, right? Notice how it's not a coincidence that that and that are the same, right? Like they're giving us the first and last term. So this is where we can use that other formula, the quicker one, right? So that looks like this. Sn equals n times term 1 plus term n divided by 2, right? So notice how, whatever here is going to be here, right? So when I do this, the sum of the first 20 terms, right? Well, it's going to be 20. We're going to replace n. Term 1 is 12. Term 20, right, is 375. There you go. Divided by 2, right? You can do this as quick as you want. Again, I'm just going to go, all right, 20 divided by 2 is 10. 12 plus 375 is 387. Times that by 10, 3,870. So that's the quicker formula, but you can really only use it for those situations when you know the first and last. Now, I didn't know what the common difference was there, right? But I know the first and last, and I know how many terms are in it. And there you go. All right, we're going to move on to a few more examples, and that'll be, let's check. Okay, so in this example, they say determine the sum of 3 plus 5 plus 7 plus 9 plus ... So this ... is saying we're skipping a whole bunch of numbers, and then we're getting to the last one, which is 113, right? So this would be our first term. This would be our last term. All right, so what do we know? Let's collect everything up. A is our first term. D is our difference, right? N, how many terms are in the sequence, right? So we know the first term is 3. We know the common difference. We can calculate that because what are we doing each time? We're increasing by 2. Okay, so D is 2. The problem is here, we do not know how many terms are in the sequence. Now, you could sit there and count them up, right? Like, well, just keep adding 2 till you get to 113. Again, what if these were really messy numbers? Remember, we're starting with simple numbers. So the idea of this is because, there's always a handful of people who go, I just counted them up, or I just did this, right? And I got the answer, what's the difference? So I get where you're coming from, isn't that just good enough? But that's not the point of the lesson. The point is to master these formulas so we can do it on much more complicated sequences and series, right? We start on easy sets of numbers that, you could just sit and count them up and you could just do it, right? Because we don't want to start on super challenging, nightmarish problems, right? We want to master them on simpler things and then move to more complex things, especially as you move into grade 12 in university, okay? All right, so what we need to do is determine how many numbers are in the sequence, right? What is the last number? So we need to find this one's term number, right? If we could find its term number, then we'd be good because whatever that is, that's how many there are. So what we need to do is use our old formula. So step 1 here. All right, step 1, what we want to do is set up the general term. So remember that formula. So we still need that formula quite a bit. And I think we're using it in a lot of these questions, okay? So the general term, let me just write this down, gen term. Sorry, a little sloppy. All right, so remember this formula from the first lesson of this unit. Tn, so you still need that. Write it down even, so you have it handy. It's in the textbook too. Tn equals a plus n minus 1 times the difference. All right, so that's our general term formula. So let's set up what we know. We know a and we know d, so we can set this up, right? The general term, Tn, remember Tn basically means any term, right? Now sometimes it could be our last term if that's what we're talking about, right? N meaning any term, any number, whatever you want, is 3 plus the term number minus 1 times the difference. And let's just clean it up, right? All right, so I'm going to distribute the 2. I'm going to have 3 plus 2n minus 2. So our general term is 2n minus 1. There, you can find any term using that. Okay, so we've actually already done this question. Actually, all these questions coming up, I think we've actually already done the skills we need in the first lesson. This is actually review. We've done this. We've found, there was a question I gave you on the first lesson that said, find the term number of the last number, right? Like how many terms are in the sequence. So we've already done this. So this is actually an old skill. All right, so step 2. Well, if we have our general term, what we're going to do is let's sub in the last number and find its term number. So this is, again, if you're thinking this is something familiar, you're right. We've already done this. So sub in the last term and find its term number. Okay. All right. So what we're going to do is we are going to set Tn equal to 113. All right, so 113, I'm just basically this formula right here, okay? So 113 is equal to 2n minus 1. This is a grade 9 linear equation, two-step equation. What are we going to do? We're going to go 113, we're going to add 1, and we're going to divide by 2. There you go. So what's 114 divided by 2? You're going to get 114. Wait a minute, I'm looking at my numbers here. I made a mistake. Some of you are probably caught this, right? And you're like, oh, Colty, you already goofed up. 3 minus 2 is not negative 1. Come on, Colty, you're killing me here. It's positive 1, sorry. Positive 1 here. I'm looking at my numbers saying, wait, something's not making sense because I don't know how to add. There we go. All right, 113 minus 1 is 112. 112 divided by 2, there we go, is 56. Sorry about that. Now we got it fixed up. All right, so now we have that term number. Now we can just use that formula that we learned today. So really, this stuff here is all, right? This is from the previous lesson. So you're going to find that's the case with a lot of this stuff. This is from our lesson 1 of this, right? Whatever it was. I'll just call it lesson 1 from our arithmetic sequence lesson. Arithmetic sequence, right? We already learned how to do this. So that's old. And then all we got to do here is just do what we learned today. Just use our new formula, right? So what we're going to do is use one of our new formulas. Okay? Now, we can use the shorter formula here. Why? Because I know the first and last. You could do it the long way or the short way. I'm going to use the short formula. So the shorter formula, remember, is this one, which is the number of terms, first term times the first term plus the last term, divided by 2. Now, you could use the longer formula. Let me just go back and look at that. You could use, we had both of them, right? You could use either of these in this case. You could use this one. Why? Why can I use this one? I know the number of terms. I know the first term. I know the difference. So that works. Or I'm going to use the shorter one because I know the last term. So you will get the same answer with both. So if you're like, well, is it better to use one or the other? It doesn't matter, right? I'm just going to use this one because it's shorter, right? All right, so now we know how many terms are in the sequence, right? N is going to be 56 terms. So I'm just going to take all these numbers here, I'm drawing the box around, and sub them into this formula. All right, so the sum of the first, how many terms again? Oh yeah, 56, right? That's what we just found. Is 56 times the first term, which is 3, plus the last term, 113, divided by 2. All right, so you can punch that in your calculator as quick as you want, right? You go 56 divided by 2, right? Times that by 3 plus 13 is 116. You punch that on your calculator and you should get 3,248. So that would be my final answer. That is the sum of the first 56 terms, which is all the terms in this series. Pretty simple, right? So this part here is just the new formula. So like I was keep saying, right? Most of what we're doing now is just, we're basically starting from what we already learned, and we're just gonna, at the end, find the sum of it, right? So these problems are all generally the same problems again, except the only difference is at the end you add them all up, okay? All right, so let's check out another one. Okay, so this question says determine the sum of the first 16 terms. Okay, so I'm going to make my little tally over here. So what they actually want us to find is sum of the first 16 terms, right? where term 12, okay, so they're telling us one of the terms. They're telling us term 12 here is 84 and the common difference. So the problem here is I don't have A. I don't have the first term and last term, right? So I can't just use that formula really quickly. I need A and D then, okay? So we don't know A. We know the common difference is 5. We're adding 5. And they told us term 12 is 84. Now we've run into a question like this before also. So the idea is we're missing this, right? If we could find A, then there'd be no problem to find the sum of the first 16 terms. So we need to find A. So how are we going to do that? All right, so we are going to use the general term again, okay? This is where, again, normally in class people are having problems because they keep trying to only use the new formula, right? Well, we need the general term first so we can solve for A. So our general term, again, for an arithmetic sequence and series, right, or arithmetic sequence, sorry, is A plus the number of terms minus 1 times the difference. Now, what can we do? Why don't we sub in everything that we know here, right? We know D, so we can sub that in. We don't know A, but we could sub in and make N 12 and make Tn 84. So in other words, we could sub that in temporarily. It's like subbing in a point right into the equation of a line to solve for a missing piece of information, like your slope or something. It's the same idea. Sub in what we know, and we'll use that to solve for what's unknown. So in other words, let's set Tn equal to 84. We don't know what A is, but let's set the term number temporarily to 12 because we know the 12th term is 84. Subtract 1 and times it by the difference. So notice when we sub everything in, all that's left to solve for is A. All right, so what are we going to do? 12 minus 1, right, is 11. 11 times 5 is 55. So I'm going to have 84 equals A plus 55. Hey, this is easy, right? Just got to subtract 55. Make sure I actually know how to add and subtract. Right, and I get A is 29. All right, so that's all there is to it. So they're not super difficult questions. It's just a lot of people stare at the formulas and they're trying to use the wrong formula because they get hung up on the idea that we're finding the sum. So everyone wants to use the sum formula to start, but you need the general term to solve for what's unknown, okay? So now that we have A is 29, now we can use the sum formula, okay? So that's basically it. They're not really challenging questions. It's just people get hung up generally on using the wrong formulas at the wrong places, right? Okay, so now let's find our sum. So what's our sum formula? Again, I can't use the short one where I know the first and last because I don't know the last term, right? All they want me to do is find the first 16 terms. So I don't know the first or the last. Well, I know the first, sorry, I lied to you. I know the first is 29. I just mean I don't know the last. All right, so here we go. N times 2A plus N minus 1 times the difference divided by 2. So just sub everything into that. So the sum of the first 16 terms is equal to 16 times 2 times the first term plus 16 minus 1 times the difference of 5 divided by 2. All right, so when I do this again, what I like to do is I just go 16 divided by 2 is 8. All right, 2 times 29, right? What's that going to be? 58 plus 16 minus 1 is 15. 15 times 5 is 75. All right, so we just got to go 58 plus 75, times that by 8, and you get 1,064. So for a lot of these, I know I'm repetitive, I'm sorry, but again, it's generally you're going to use the general term formula from our previous lesson, and then once you get all the information you need, you just plug it into the sum formula. All right, I have one final example here to do with you. Okay, in example 5, we're asked to determine the sum of the first 16 terms in an arithmetic sequence where term 5 is 17, term 12 is going to be 150. So I'm changing the numbers up a little bit just so it's a little easier on this first example, or this last example. So the key here is, let's think about what we have. Like, what do we need normally, right? We need the first term, that's A in our equation, right? So we need that. We need the difference generally, right? Sometimes we can solve this if we know the last term, right? But we don't know that because we're looking for the sum of the first 16 terms, and they gave us term 12 and 5. So neither of those are going to be the last term. So if I don't have the first and last term, I can't use the shorter formula. I'm going to have to use the longer formula, right? All right. So essentially what we have here are two unknowns, right? We don't know what A is, and we don't know what D is. So that's a problem, right? So when you have two unknowns, you need two equations. Let's look back just really quickly at the previous question here, right? We had one unknown, right? We didn't know what A was here, right? We had no idea what A was. We had to solve for it. We knew what D was, right? If we look up here, I kind of doodled all over this already, but we knew what D was. The common difference was 5, right? We knew D. We didn't know a. So we only needed one equation with one unknown, right? So what we did is we subbed in, think about it, we subbed in a point, basically, is what we've done. We subbed in when n is 12 and term was 84. We subbed it in, we subbed in d, and we solved. So one equation for one unknown. Now we have two unknowns, which means we need two equations. And this is a standard thing, not just for sequence and series, for anything in math. Generally, the number of unknowns you have, that's how many equations you need to solve. So if you have three unknowns, like an x, y, and z, you would require three equations to solve for that, and so on and so forth. Four unknowns, four equations, right? So what we're going to do here is we need to set up a system of equations, right? Because we don't know a or d. So step one, we need to set up a system of equations. So we're going to make two equations using the general term, okay? All right, two equations using the general term, because that's our equation we use, right? If we were doing straight lines, right, we use y equals mx plus b. If we were doing two parabolas, we'd use, y equals ax squared plus bx plus c. We use the two equations of what we're working with here, right? So we're going to use the general term here. And that's the name of this equation. Okay, so let me set this up here. So let's go with, so we have two pieces of information. They told us the fifth term is going to be 17, and they told us the 12th term is going to be 150. So what's our general term equation? Tn, which is the general term, equals a, the first term, plus the number of terms minus 1 times the difference, right? So what we're going to do is we're going to substitute what we know into these equations to solve for what we don't know, right? So we know the fifth term, so n is 5, is 17. So let's make the term 17. And we'd end up with this. 17 equals a plus 5 minus 1 times d. So let's just clean that up a little bit. 17 equals a plus 4 times d. Okay, 4 times d. There we go. All right, now what about this one? We know the 12th term, so we can set n to 12 is 150. So set the term itself to 150, and we have 150 equals a plus 12 minus 1 times the difference. Okay, so 12 minus 1, 11 times d. So we have two equations, right? So again, this is the same thing like when we were in grade 9 and we were finding in the start of grade 10, finding the point of intersection, right, between two lines, right? We are trying to find what is that x and y coordinate. You could really think about this. These are just two linear equations. Like we could graph these, but instead of using x and y, we're looking for the point of intersection of a and d, or d and a. It really doesn't matter, right? That's all we're doing here. It's a system of equations. It literally goes back to the end of grade 9, start of grade 10 topic, okay? So how do we do that? Well, remember, we can use substitution or elimination. So this question goes into that deeper math topic that comes up a lot, systems of equations. When you're solving for unknowns, you need equations. One unknown, one equation. Two unknowns, two equations. Three unknowns, three equations, and so on and so forth, right? So what are we going to use? I'm writing sub here. Let's just use elimination. Elimination is going to be the easiest, so let's use elimination. Now, elimination method essentially means you take one equation and you subtract the other, right? So let's just put, I'm going to put the one with the higher numbers up top, the 150 equals a plus 11d, and I'm going to put the one with the 17 on the bottom. It really doesn't matter though. All right, so to eliminate them means we're going to subtract, right? All right, so I'm going to subtract this entire equation. So 150 minus 17 is 133. Now, why is it nice to subtract them? Because what happens when you go a minus a? Perfect, they cancel out. That's what we want. We want to get rid of one of the variables, so there's only one left to solve for. And then 11 minus 4 is 7d. So notice it's canceled, the a is gone. So this is a super, super common technique. I know we first learned in grade 11, we've used it, or 10. Actually, some of us even at the end of grade 9, we did a bit of this. We used it a lot at the start of grade 10. This is one of the most common methods. So this method should start feeling really familiar to you, the idea of two equations and two unknowns. So as you progress in mathematics and you run into problems where you have unknown variables that you need the values for, that's when the light should go off and go, oh, this is a system of equations question. How many unknowns do I have? How many equations do I need to build? What's the equation I'm working with, right? Again, if this was straight lines, we'd use y equals mx plus b as our equations, right? Which technically these equations are straight lines. If we were doing, parabolas, ax squared plus bx plus c. If we were doing, exponential equations, right? A times b to the power of x or things like that, okay? So you basically, what type of system am I working in? Linear, quadratic, exponential, etc., sinusoidal, and then you set up your two equations and then you use elimination or substitution generally. Okay, so to finish this guy off, we need to divide both sides by 7. All right, I'm just going to flip it around here, and when we do that, 133 divided by 7 is 19. All right, so we just found one of our unknowns, right? D is 19. Cool, we got that. So we just need to find A now. So now we have one unknown. So we only need one of these two equations. So what we're going to do is pick one of these two, either this one or this one, right? One equation, one unknown, substitute in the D, solve for A. All right, so let's do that. So step 3, right? Substitute what you know. So we know D is 19, right? Into which equation do we want to sub it into? So I can number these things. I probably should have from the start, like this is equation. We'll call this equation 1 and equation 2, right? There's 1, subtract 2. Just a lot easier as you get into more complex. Since we're only doing 2 simple equations, it's not so mandatory, but this is really the system you'll see a lot of your professors use in university. All right, so let's, I don't know, let's just sub it into equation 1, right? There you go. Okay. So equation 1 is 17 equals A plus 4D, or you can flip it around. We're going to replace the D with 19, multiply it by 4, and away we go. What are we going to go? That's going to be 76. And then we're just going to subtract from both sides, and away you go. There's A. All right. So this is the exact same method that we used in the very first lesson. Like I was starting out on this question saying, it's 2 equations, 2 unknowns, right? Well, now we've got it. We've got our 2 unknowns. Now we can actually answer the problem. So when we were started with arithmetic sequences, the question said find term 16 or something like that, right? In this case, I'm saying instead of find term 16, find the sum of the first 16 terms. So the only thing that's changing now is this last step. So the 4th step, now we can finally find sum 16, sum of the first 16 terms, right? All right, so let's get out our equation. What is the sum formula? Now, I don't know the last term, so I can't use the shortcut one, but here we go. We're going to use this guy. Number of terms times 2a plus n minus 1 times the difference divided by 2. So the sum of the first 16 terms is we're going to make n16, 2 times a, which is negative 59, plus 16 terms minus 1 times the difference, which is 19 is the difference between each number, divided by 2. All right, so, I don't know if we don't need to watch me do every single step here. Obviously, you can go 16 divided by 2 really quickly and just make that an 8, so we can eliminate the fraction right away. 2 times negative 59, negative 118. 16 minus 1 is 15 times 19 is going to be 285. All right, so I'm going to go, what's 285? Minus 118, times that by 8. And the sum of the first 16 terms is this. Now, again, what you're looking for is it's less of, hey, just getting this answer. Like, obviously, we want the correct answer, of course. But what we're really testing you on is the idea that, do you know how to set up a system of equations? Do you know how to use elimination or substitution? With this case, elimination is really easy, right? And then sub it and solve. So we're really reviewing the grade 10, start of grade 10 skill when you did systems of equations at the start of grade 10. That's what this is, really practicing and reviewing, starting to hammer home that this kind of skill is going to start popping up more and more and more, okay? All right, so that's the last example for this one. We're going to do one more lesson, and it's pretty short. Thanks.